Today we're going to continue our discussion of linear equations, and we are going to look at a couple of things. One thing we're going to look at is parallel and perpendicular lines, and then the other thing we're going to look at is some very concrete applications of linear equations, everyday kind of stuff, okay? So parallel and perpendicular lines is our starting spot. Parallel lines are lines that have the same slope, and if you think about how we draw them, it should make sense. Right? They're the same steepness. They're the same direction. So their slopes are the same. Perpendicular lines have slopes that are negative reciprocals. So if you have one that's a positive slope, you're also going to have one that's a negative slope for them to be parallel. For them to be perpendicular. And if you had, let's say that this one's slope was 3, what would this one's slope be? Negative what? What's a reciprocal of 3? 1/3. Reciprocal, remember, means we flip the fraction upside down. We've talked about it when we've talked about fractions, reciprocals. Sometimes these are defined that the slopes are multiplicative inverses of each other, okay, but negative. So one's positive, one's negative. When you multiply them together, you get -1. Right? You always multiply the two slopes for perpendicular lines together to get -1. All right, so we're going to look at a few examples of parallel and perpendicular lines. Our first example we're going to look at is the equation y equals -1/4 x minus 2. And to start with, we're just identifying what is going to be the slope of a line that's parallel to this line. Parallel. The same. So what is the slope of this line, Megan? Right. So the slope in this particular line is already -1/4. So when Megan said that it's going to be the same slope, she's right. The slope for our parallel line is going to be -1/4. But then if we did the reciprocal, if we did the perpendicular line, we would do the reciprocal, which is the other piece you were saying. And Megan, what would be the slopes of the perpendicular line on this one? It would be 4. So I'm going to reciprocate, right? That's not the right word. That's a different word. We're going to do the reciprocal. So the reciprocal of 1/4 is 4. And then I'm going to change my sign. It was originally negative, so now it's positive. Okay, any questions on that? Okay, what about this one? This line is 2x minus 6y equals 4. The questions are the same. What's the slope of a line parallel? What's the slope of a line that would be perpendicular? But how is this problem different than the one before? It's not in slope-intercept form, right? Yeah, I can't just look at it and say, oh, I know what the slope is. Over here, I really hope that when you look at that line, you can immediately tell me what the slope is. It's -1/4. You should be able to do that. Over here, it's not so straightforward as that. So I need to get this solved for y in order to be able to look at it the same way as the last problem. So the first thing I would do is I would subtract my 2x. So I have -6y equals -2x plus 4. And then I would divide by -6. So I have -2x divided by 6, which would be positive 1/3 x. And then 4 divided by -6, although it doesn't really matter for the sake of our question, is -2/3. So in that form, can you identify for me what's the slope? It's 1/3. Good. So what is the slope of a parallel line to the line that we're given? It's 1/3. And what is the slope of a perpendicular line to the one we're given? -3. Okay, so we've identified how to find the slope of the parallel or the perpendicular line. Next, we're actually going to find the parallel or the perpendicular line. So the line we're going to start with is y equals 3x minus 8. What is the slope in the line that we're beginning with? Don't everybody yell out at once. It's what? What's the slope of this line? It's 3. Okay. Slope's 3, right? Yeah? Okay. Some of you were saying it so quietly and you're looking so doubtful of yourself, I can't even hear if you're right or wrong, so I'm not sure. Yeah, it is 3. So on part A, when it talks about having a parallel line, our slope will also be 3. When part B talks about having a perpendicular line, what will that slope be? Yeah, negative 1/3. So that's sort of the problem we already did, right? We've identified the parallel and the perpendicular slopes. But we're actually finding the line itself, or the equation of the line itself, through a particular point. And when we did this last time, we did it with the y equal mx plus b equation, right? We used the x and the y that are given, the slope that we know we have, and we can solve for b. So the y value is negative 6. The slope value is 3. The x value is 7. And the b value is what I'm looking for. So what is 3 times 7? 21 plus b. And then I would subtract the 21. What is the b value here? Negative 27. And then we want to make sure we answer the question that was asked. So what question, or what is the answer to the question that was asked? Yeah, to find the equation. So it would be y equals what? 3x minus 27. Okay, same thing on part B, we just have a different slope to work with. I have the same y and x values, so the y value is negative 6. The slope, however, is negative 1/3. And the x value is 7 plus b. Okay, so I have negative 6, and then negative 1/3 times 7 would be negative 7/3. So I have to add 7/3 to the other side. If we're going to add fractions, they have to have what? Yep, they got to get a common denominator. So if I take a look at negative 6, it's really negative 6 over 1, right? And I can multiply the numerator and denominator by 3. So I can actually have negative 18 plus my 7 over 3 to equal b. So my b value is what? What's negative 18 plus 7? It's negative 11 over 3, right? So what's my equation? Okay, so I'll put minus 11 over 3. Plus negative is fine, but yeah. Okay, are we clear on parallel and perpendicular lines? Okay, because we're going to shift gears to the other sort of portion of this lesson, okay? This is where a lot of the writing kicks in. So here's our first example. The Sugar Sweet Company is going to transport sugar to market. It will cost $4,500 to rent trucks and an additional $225 for each ton of sugar transported. Let C represent the cost in dollars, S represent the amount of sugar in tons it's being transported, and write an equation relating C to S. Then use the equation to find the total cost to transport 13 tons of sugar. So first of all, just get it all written in. Okay, we've seen some problems of this variety before. We saw a problem that talked about cell phone bills, and it cost, or it wasn't a cell phone, it was a long distance bill on a phone. And we had the fixed cost of a certain amount of money per month, and then we had a per minute cost on the phone calls. This is very similar. We have a fixed cost here. What is the fixed cost to transport this sugar? Yeah, $4,500. That's what it costs to rent the trucks. And then the additional sugar inside of it has a transportation cost itself. And that additional transportation cost is what? $225 for every ton, right? So if there's 1 ton, it'd be $225 more. But if there's 2 tons, it would be times 2, right? I'd have 225 times 2 or $450 additional for the tons of sugar. Does everybody make sense with that? Okay, so we're going to write an equation that represents the cost of our sugar. So the cost is what we're actually finding. That's C. And it's identified for you here. So on these, you don't have to identify C equals cost. They told you that. How nice of them, so friendly, right? So there's a lot more context to these problems, but C is in there and already identified. C is cost. And the cost is equal to $4,500, that's the guaranteed fixed rate, plus, and then the variable cost, what changes? Well, it's $225, and it's based on how many tons of sugar that I have, and that's exactly what S represents, the amount of sugar in tons. See that there? So it'd be $225 times S, the number of tons. So this is sort of the first part of the question where it says, if you will, this is like part A, write an equation relating them. That's what we just did here, write the equation relating them. Part B says, if you will, I'm supposed to use this equation to find the cost for transporting 13 tons. So this is like part B right here. So what would I do to find how much it would cost for 13 tons? What was that? Yeah, I would actually use the S in my equation to represent the number 13 now. So my cost would equal the 4,500. Whoops, I left my 5 out. Plus the 225 times the 13. The 13 is how many tons of sugar we have. So if you multiply 225 times 13 and add the 4,500, what do you get? What was it?
2,925.
Was that with the 4,500 added or not yet?
No, not yet.
Okay, add the 4,500 and tell me what you have, Macy.
It is 7,425.
Excellent. And context problems will always have unit answers, right? It will have context with the answer. So what are the units for this answer? It's dollars. So I have $7,425. All right. Oh, my screen froze for a second. There's my answer. Okay, so another one. We've got several of these, and we'll see if we can finish them, I'm hoping. Here's our next one. Carmen is a software saleswoman. Her monthly salary is $1,900 plus an additional $40 for every copy of Math is Fun that she sells. Let S represent her total salary this month in dollars, and let MN represent the number of copies of Math is Fun that she sells. Write an equation, that should be and, not and. An equation relating S and N, and then this one says to graph our equation. Graph our equation. Okay, so if she doesn't sell anything, she's making $1,900, right? It's the guaranteed salary. Make no mistake, she doesn't sell anything, eventually she's going to be fired. That's not going to go on forever. But she has a base salary. And then she's going to be paid additional amounts for this particular software that she has apparently been encouraged to sell. Okay, so like on the last one, we're going to create an equation that relates, in this case, the letters S and N. S is her total salary, how much money she makes, and N is the number of copies that she sells of this particular software, Math is Fun. So what would you let your equation be? What would it become for this particular situation? Okay, that sounds great. Good job, Sarah. Any questions on where the pieces came from? Okay, got the $1,900 in there, the fixed cost, and then the the $40 times SN, blah. $40 times N, the number of copies she sells of the software. Now, in terms of graphing this equation, when you do these on your homework, they'll give you, of course, a XY axis. But for what we're doing right now, just understand that this is the y equal mx plus b form, right? This is like 40x plus 1900. I mean, that's how it's graphing. So the 1900 would be your y-intercept, right? So you're going to have a y-intercept 1900. And then you're going to increase for every one on the x-axis, or one sale, you're going to increase $40. So this would be 1940, sounds like a year, on the y-axis. If we went again, if you wanted to do a second point, you would actually have 1980, right? And so on. So this would be your equation that you would be, sorry, not your equation, your graph that you would be plotting. But they'll have a grid for you to fill it in, so just make sure you're using their grid, of course, that they've got.
And so all we'll have to do is plug in the numbers.
All you'll have to do is to make sure that you're plotting the right values from your equation. So in your equation, you'll have the base salary, or the base whatever it is, the fixed cost that you would plot, and then you would have your slope that you're plotting after that.
So that means we write that in on the graph and stuff, right?
Yes, yeah, because it'll have the grid marks on there otherwise. So, all right. On this one, we're actually given a graph to start with. So I've got 3 slides for this, but they all have the same first part. All that's changing is A, B, C. Can you guys watch me flip through this? Okay, so you C here, B here, A here. Okay, so don't rewrite this 3 times. That would be highly ineffective. Inefficient anyway. Scientists are measuring a distant planet's temperature. This graph shows the temperature in degrees Celsius above the planet's surface. So you'll notice on the y-axis it says degrees Celsius. On the x-axis it says height in kilometers. Question A asks, at what height above the planet's surface is the temperature 0 degrees Celsius? So where on this graph is 0 degrees Celsius? What is it, Trey? Give me a guess. Where do you think it is? Not sure? Okay, somebody else, give me a guess. Where do you think 0 degrees Celsius is on this graph? It's at 0 on which axis? On the, okay, so where visually, can you give me up, down, left, right, where are we if we're at 0 degrees Celsius? We're at the bottom, right? This is 0 degrees Celsius, 4 degrees Celsius, 8 degrees Celsius, 12, and so forth. So this is 0 degrees Celsius. And at 0 degrees Celsius, we would be along this axis on the bottom. Everybody good with that? So along the axis on the bottom, I'm at 0 degrees Celsius, but on my graph, right, the diagonal line portion, where do I actually cross that line that is the x-axis? At 3, right? And that line, or that, the x-axis at the bottom right here, is representing the height. So this location right here tells me that I'm at a height of 3 kilometers. So the height above the planet's surface is 3 kilometers. Who's flown in an airplane before? Have you ever noticed that the windows are really cold? Yeah? Because the further you get away from the surface of the Earth, right, the colder it is. So as this particular situation is occurring, the height of 3 meters is when I had hit the 0 degrees Celsius. Does that make sense? Okay, so second question. Same picture, same everything at the beginning. What is the relationship between temperature and height? In particular, we just sort of talked about as your height above the surface increases, what happens to the temperature? It drops. So we would actually call that an inverse relationship, mathematically speaking. What we're asked to do here can be much more basic, and we can actually just say that as the height increases, the temperature, you can use the word drops if you want. You could also say decreases, sort of mirroring the language I used at the beginning. Height goes up, temperature goes down. Right? Yep. And then the last question is, how fast? At what rate is the temperature decreasing? Here's what you need to know. The word rate is a synonym for a word we've been using in these two sections all the time. Do you know what it's a synonym for? Somebody almost said it. Speed. Another word. We haven't used speed quite as much in these. Slope. This is equal to asking you what the slope is. What is the slope of this line? And we should be able to do that, right? I have this point already marked. We already talked about it. It's 3, 0. Do you see another point on here that's very nicely marked? 0, 36 is also very nicely marked. So you can either count from the graphical perspective, how many do I go down and how many do I go right? That'll be fine. Make sure you're not counting grid marks, right? Like don't count this as 1. That's not 1, right? It goes from 36 down to 32. So that's 4 down. Or you can do an equation perspective, right? So I'm going to use the graph. We have it here. So if I go all the way down to here, how far down have I gone? 36, because I was at a height of 36 before. So I've decreased 36. And then if I move to the right, how far to the right do I move? 3. And this simplifies to what? -12. Everybody good? -12. But this has context, right? It's -12 what? Well, let's go back and look. What was 36 representing? It's the temperature. It's the degrees Celsius. What was the 3 representing? The height in kilometers or kilometers, right? So this would be degrees Celsius per kilometer. What that's saying is that for every kilometer in height you go up, you're going to decrease your temperature by another 12 degrees Celsius. All right, here's the deal. I have 2 questions left that I would like for you to be able to do. So I'm going to give you the homework, and it's not going to be due next time. But I'm going to give you another homework next time. So if you get this homework for me today and you wait to do it, how many homeworks are you going to have after class on Wednesday? 2. On church night, right? Wednesday night. I know a lot of you do go to churches or you volunteer at churches. Lots going on Wednesday nights. So I would encourage you to please begin this homework, but know that it's not actually going to be taken up next time, okay? All right.